Next up, we're going to have Madi Youssef, who will talk about the twisted history of Python packaging.
Okay. Hey, everybody. I'm going to not talk about Twisted. It's going to be about Python packaging, so just so everybody's clear. I told the guys in my usual meetup group weekly the title of the thing, and everybody's like, they're going to think it's about Twisted, blah, blah, blah. I was like, no, I'm going to stick with the title. So if anybody leaves now, I'm not going to complain. I find a lot of the stuff that's been done with Python packaging has been an evolution or a growth, and I think the history needs to be discussed and talked about, just so we understand where we've been, so we can hope to do a better job in the future. Can I get a show of hands of how many people have created a package in the past? And a show of hands who've put hacks in setup.py. Okay, who didn't raise their hands the second time, you guys are probably lying. But we'll just keep it going that way. So I'm Madi Youssef. I'm one of the people who set up PyCoders Weekly every week. I'm a full-time Django developer. A lot of my code's on GitHub. On the internet, that's how I look for most of the time. That's how I look in real life. So that's me from long and short of it. So this, as I said earlier, it's a discussion of growth. So if I go too fast or skip over something, please come afterwards and I'll clarify. A lot of it can get convoluted, so I have discussed a topic and then I keep in mind which packaging tool is being referenced as I'm talking about it. So it'll be in the bottom right-hand corner. I don't know if those of you in the back can see, but hopefully you will be able to. So starting everything up, the whole song and dance of packaging is maintained by the setup.py. And he's sitting there like a politician going, I'm going to take care of you, and I'm going to take care of you. So he's promising things about the metadata, he's promising things to the developers, end users, operating system packagers, all these types of things that need to go in and be solved by the packaging tool. And setup.py is sitting there going, promising a bunch of things to everybody, and to me that's quite hilarious. Because there's a lot of constraints that you're trying to combine into one particular thing, and it gets kind of convoluted in terms of all the different types of constraints you have and all that. And I think level of abstraction might be the solution, but again, people like to discuss these things to death. So here's a sample setup.py for one of my projects. I don't expect anybody to read this, but they generally contain a lot of metadata that's for each of the packages, so PyPy or the TreeShop can read them, and other convenience functions, dependencies, and depending on what kind of tool that you're using. And you do some things like adding things into path and importing things for versions and stuff like that. So that's the type of things you see commonly in setup.pys. That's just a sample for mine. I'm going to begin the talk with disutils, which is the very first iteration of Python packaging. A lot of people, well, let's start with that then. A lot of people, originally when they were starting it out, that's what initially would be a disutil setup. We just have the name of the package, a version number, the Py modules that were in that particular version. And then to package it, all you'd have to do is run the setup file with a standard distribution. That would create a package in your local directory that you could then upload to PyPI. And then when you're downloading it on the other side as a user, you'd pull it down and then untar it and then run the install file. And that's how it was done for the longest time with disutils. And you can still do things using pip to install it, but generally that's how it was back in then when that originally started, because pip and all those other tools didn't exist. So the main problem with disutils is that there was no dependency management. So if you had a package that you were using and it had a dependency on something else, there was nothing you could do. You'd have to just say, this is a dependency, you have to have it installed. There were a bunch of problems trying to gain and keep redeployable, reusable dependencies on different systems. It was a big hassle. There was no consistent way to reproduce an installation, so one person would be using a different version of the particular package. Version numbers weren't kept track of, so it caused a lot of problems and inconsistencies. Not all of the metadata was handled, so you'd have different versions for Windows, different versions for different versions of Linux, so you'd get all these inconsistencies, and it would cause people to be generally frustrated with dealing with Python packages. Then setup tools came along. It was started by Philip Eby. I hope I'm pronouncing that right. And it was built on top of disutils, so it just takes a lot of the stuff disutils has and adds things to it. There was no way to uninstall installed packages, So if you installed something with Easy Install, for example, there was no way to actually remove it with the tool you installed it with. You'd have to manually go into your site packages, delete it, or get rid of it, and that sometimes was a hairy issue, depending on how you installed it originally. The good thing about Setup Tools is it provides dependency management. So if you have a package that's using another dependency, it would just through the install process would pull down your other requirement and install it. So there are differences on how Easy Install and pip do these things. Setup Tools does all the work up front and then installs it, and PyPI goes and as it's going, creates a dependency graph as it's happening. Or sorry, pip is what I meant there. Setup Tools introduced Easy Install, which was the tool that people started to use to install things. Now in projects, you'll see people suggesting you use pip and Easy Install. I would suggest you use pip because it actually pulls down the source, not the precompiled files. They also introduced eggs, which are basically just zip files that are zip files just renamed. And Setup Tools has some magic to go and introspect the zip file, get all the files that come out. But then there's problems that arise when you're dealing with different types of data files. And Setup Tools is good. It solved a lot of problems for a long time. People still use it. I still use it. But it gets a bad rap for a lot of the problems that exist generally in packaging now. A lot of projects don't support it. For example, Django, it has no dependencies, but they do tend to pull in things that they use as dependencies into the project itself, and they use disutils. So it gets a bad rap for a lot of things, but it was a progression that we needed to get to the other side. Distribute was a fork of Setup Tools. Not much there. So Philip started Setup Tools. He was progressing with it, and eventually he just got bored. And he wouldn't give commit rights to a lot of people. Ian Bicking now is, I believe, the maintainer, and he wouldn't give the reins up to anybody else, and he wasn't working on it for whatever reason. I don't know. So people decided to fork and put fixes into it and improve the project from where it started. So that's what Distribute is. There's not much else there. Disutils has been a new effort started by Tarek Zaid, and I understand a lot of the Montreal Python guys have done a lot of sprints towards working towards this. One of the cool things that they introduced was versioning. And versioning before, you could have things like demo.unreleased up on PyPI. Somebody just wanted to install it or give it to their friend, and you'd get things like Musty Monkey where you couldn't tell which one came first. So you'd have a different version, and the problem is you don't know. So me coming from the outside, I wouldn't know which came before which without having to look it up. Or you'd have things inside quotations, all kinds of things that aren't being checked. Disutils 2 tried to formalize all of that. So the first number there is, if that number would change, a lot of the public APIs would change, and that would signify breakage generally, so you wouldn't want to upgrade to that one without checking to see if what changes apply to you. The second number is dedicated towards deprecations and features. So let's say you add a new feature and you would deploy a new version, that you'd increment that number, and then that number is the last number. So if any type of bug fix or any type of hot fix for security reasons, you put in, you'd increment that number. I think this generally should be a way that all software should be versioned, and it makes a lot of sense in terms of understanding, so everybody's on the same page. There have been PEPs that I'll talk about later that have been put towards this effort of standardizing all of this. So the setup.cfg is another file that projects include to get the metadata out. Now, like I said before, the setup.py is just any other Python file. It's very simple. It has all the metadata inside an argument. And what setup.cfg does, it pulls all that metadata out so you can look at it in a file without having to run the setup.py code attached to the particular project. So somebody might put a hack in there, or they can put things that call out things just when you want to get the name or who the maintainer is and stuff like that. So the setup.cfg was the solution to that problem. I have an example one here. So all it would be, so if anybody's read any files before, it's very similar to that. You'd have the name of the package, which is sadness, and you'd have different version numbers and my name and my email, and a summary of what the entire project's supposed to be doing, and that's how they've outlined that. PySetup is basically their iteration of Easy Install and pip for disutils. It lets you convert a setup.py file that you created previously into the setup.cfg, so you just simply pass the setup.py file and it would spit out a CFG file for all the metadata that it needed, and it can also go the other way around. It's a pretty cool tool. It's also used to install packages as well. I like it a lot. So disutils also took into fact that there are different types of operating systems, and you can specify which operating system needed which requirements. So for example, you had a package that was used on Windows versus a package that was used on Linux. You could describe that in distutils, and it would do the proper thing depending on which system you're running. So distutils 2 was supposed to be in the latest revision of Python 3, and it was deemed not mature enough, and I'm not sure what's happening in the community towards its effort. I've heard there's a couple other packages, I believe it's dislib, that some of the effort's being pushed towards now, but the general feeling that I get is that people are just fed up of the situation in terms of packaging, and they're just tired of the discourse. There's no general direction where everything's going, and there's a lot of hurdles to have to overcome, especially when they're putting a lot of effort towards all the work they're putting into the software. So a solution, I think, to that problem is writing PEPs. And I think PEPs are a good way to standardize the particular problem that we have and then to propose a solution. So previously, as I was discussing all these through, people would just take the work onto themselves and start building tools, which is awesome and great, but without taking the input of all the various communities, like I said in that political slide, where there's a lot of different parties and not considering all the use cases, so you get half solutions or where things where you have to patch it yourself. I can't count the number of projects where I've seen distutils collapsed into the project and then they've done it to build for their own particular solution. But I believe if we're organize ourselves around PEPs and to write them concisely to solve particular problems, then implement that interface, I believe that would be or I think we should attempt that way of going about it. I think it would be a good way of going about it. I'm not going to say the best. I'm just going to talk about a few PEPs that I've gotten through in the past to move the community forward in terms of packaging. Changing the version for comparison model, so as that slide said, for comparing different versions. That was the PEP that described that. Database of installed Python distributions. That is a way to standardize all the tools that are doing the installing. So pip easy install and PySetup would have a standardized interface so people could understand what's installed on a particular system and how to get a newer package, and in solidifying that interface so people can, there's a communication so I could build another tool and it can be used interoperably. The last PEP is for metadata. As I was saying, a lot of times all the metadata isn't brought into concern, and this metadata solidifies all the metadata and adds metadata portions to the setup.py. So I've been talking for a while now, and you might be wondering what should I be using when I'm developing locally. The old stuff is setup tools and easy install. You can definitely use these tools. They work. They do their job for the most part. The new hotness is distribute and pip. And distribute, as I said, was just a fork with all the improvements in setup tools. And pip is a tool that installs all your packages locally. And it has a bunch of other stuff. I'd like to talk more about it, but I only had a 20-minute slot. But pip lets you reproduce requirements easily. You can freeze the requirements you have in your current virtual env. It's quite awesome. That's all my time, I believe, and I'm done. Thank you for listening. And if you have any questions, I'd be more than welcome to entertain them. Okay, we good? All right. Here. Oh, there's one there? Okay, yeah. I think you have to come up to the mic, though, man.
Hi, yes.
Yeah.
Thanks for kind of summarizing the state of things.
Yeah.
This is more than a question, kind of a comment from one community that has struggled with this, which is the scientific community.
Yeah,
for us,
and I understand that. It's a big problem. Yeah.
For us, basically, this has been the 10-year thorn on our side.
Yeah.
And people from our community have tried to engage the process pretty directly, and it have bounced kind of off the wall in a very unproductive way. So at this point, basically, the scientific community has taking the strategy of following the PEP discussion and seeing what we can take from there. But now we're getting funding and teams to basically build a solution that works for us. The compilation and linking and distribution problems that we have are about 3 orders of magnitude harder than anything that anyone else kind of faces. The supercomputing environments are nasty.
Yeah, I get that. Yeah.
And so basically we've had to decide, after meeting with Guido earlier at PyData at Google this year, we realized that the only way out for us was to build our own stack, pretty much, and that's what we're doing now.
I understand that. I'd urge you to try to go back in with the rest of the community. But again, I get your requirements and then you have to do work. But I would urge you to try to work with everybody else towards solving a general packaging problem for all of Python.
We will. We'll do our best. And I mean, we're keeping the PEPs very close. We're watching the PEPs very closely. And there's a good chance, because our problems are in a sense harder, building wise and compilation wise, much harder than anything that anyone else sees. There's a good chance our solutions will work for other people. But we've sort of waited for 10 years for this one to be solved, and it hasn't happened. And this is the biggest problem blocking scientific Python worldwide is packaging. That is the single biggest problem we face. So we basically said, okay, screw it. We're just going to solve it ourselves.
I understand. Thank you.
Thanks.
I just want to clarify a little bit of the history. I was there. I wrote distutils. After starting the design process at this was like 5 years before there was such a thing as PyCon.
I would have spoke to you before
Houston
I spoke.
In 1998. Distutils was never intended as a packaging system. It's a build tool.
Distutils original. Okay.
So we thought briefly about version numbers and dependencies, and we said, no, Debian and Red Hat have pretty much solved that problem, and the bits that they haven't solved are obviously really difficult, so we're not going there. We're going to leave that up to the operating system. That was a deliberate limitation, and we didn't want a packaging system. We wanted a build system. That's the reason.
Hi, I fix bugs in distutils and I worked on distutils too. Just wanted to say that for the next direction, I proposed a panel at PyCon US so that people can sit together and say, what do we do now? Because I can tell you if we're going to finish distutils 2 or bless distlib or something else. I would like to extend a hand to the scientific community, because most of the packaging guys are web guys, and if you don't tell us what the problem is with compilers, we can't work on it. So I think there is space for more PEPs, because not everything is solved, and we can do something. Seriously, it's programming. It's not rocket science. So we're going to sit down and say, what do we do now, and try to fix it.
Excellent.
Tried for 2 years on a list.
I know.
1 minute.
There's a limit to what David can take in terms of just spending time on a mailing list.
Sorry. I understand. I didn't mean to cause a flame war, internet. Thank you.